Hello and welcome students to our YouTube channel STEMverse, and today we are going to discuss about the number system. So as we go forward, let's find out what type of numbers are available in our number system. So when we talk about number system, first thing comes under your mind is a number line, which starts with some real numbers like 1, 2, 3, that day to day life we are using it. So till infinity, consider a number line from 1, 2, 3 till infinity. So the mathematician given the set of this number as some name. They called it as a natural numbers, which is denoted by n. But what if we have add the number 0 also in this list of series? So then you call it as a whole number, which is denoted by capital W. But as you can see, there is still left side of the zero number is still empty. So all the negative numbers comes in this, and we call it as a integers. So minus 1, 2, 3, like that, minus infinity, and all these numbers are called as the series of all from minus infinity to plus infinity are called as integers. So going forward, consider a number between 0 and 1. So what do you think, how many numbers will be available in between them? Answer is infinitely many numbers. Because if you see 1 by 10, right, it is also in between 0 and 1. What about 1 by 100? That will be also between 0 and 1, because the value is 0.001. So 1 by 10, which is equals to 0.1, which is greater than 0 and less than 1, right? What about 1 by 100? It is also greater than 0 and less than 1, right? Same like 1 by 1000, 10,000, and it can go on till infinite. No matter how much denominator you increase, still the number will be in between 0 and 1. So as you can see, there is some form between this number, like there is some numerator, there is some denominator, and that's why a number which can be denoted in the form of p by q, where q, so this is p, this is q, and q should not be equals to 0, also q should be an integer, then we call it as a rational numbers. So to give you example, 1 by 9, 1 by 7, 1 by 5, like that, infinitely many numbers will be available between 0 and 1. And all these numbers are in the form of p by q, that's why you can call it as a rational numbers. And similarly, from 0 to minus 1, the negative part of these numbers will be available. That's why we can call it as a rational numbers, which can be noted in the p by q form, and the q should not be equals to 0. And it is denoted by the letter capital Q. But did we left some numbers in our number system? So answer is yes. And that numbers are called as irrational numbers. So if there is some number which cannot be written in the form of p by q, then it is called as irrational number. But we need to take into consideration that the number, first thing I need to clarify you here, sorry for this, all the integers can be represented in the form of p by q. Like if there is a number 10, it can be written as 10 by 1, correct? So if there is any number which cannot be written in the form of p by q, then we can call it as a irrational number. And to give an example for this is root 2, root 3, root 5, pi, 0.101010, like that. It will go recurring. So you can write this equation, this number as a 0.101101 recurring. Because after this 01 is recurring, 01 is recurring, and it will continue to be recurring. So this number you cannot be able to write in the p by q form. Okay. Now to give you some pictorial values of how pi value is changing and why you cannot write it in p by q form, I am giving you this video. I am showing you this video. So actually pi is nothing but 22 by 7, and in short form we write it as a 3.14, but this is the number of infinitely many this is the series of infinitely many numbers. Look, start with 3, then 0.14, then 5, 9, 2, 6, 7, 8, 0, and it is continuously changing. So that's why we cannot write it in p by q form, and that's why pi is an irrational number. Now going forward, I just want to give you one simple example like how you can write a recurring number or how you can find a recurring number from a division. So if you do 10 divided by 3, where 10 is your dividend, 3 is your divisor, and quotient and remainder we are going to see. So once you do the 10 divided by 3, first you will multiply with 3 and you will get the number 9, and then you will subtract the 10 from 9. The remainder will be 1. But again you need to divide 1 by 3. So as this number is not divisible, you need to add 1 0, and for that we are giving here 1 decimal point. So then again 3 into 3, 9, again remainder 1, again 0 we are adding, again 9, again 1, again 9, again 1, like that. Your quotient will become 3.333, correct? And this number of series will continue forever. So if someone asks you what is the value of 10 divided by 3, you should say 3.3 and recurring. Recurring means this 3.3333, this will go on till infinity. Hope you understood this, and here remainder is 1. Okay, nice. Till now we have find what type of numbers available in our number system, but now we'll check what are the operations we can do on our numbers and what will be the output of that. The first example is, what if there is some addition or subtraction between any rational number and irrational number. So as you can see here, 2 is a rational number, 2 root 2 is a irrational number because root 2 is a irrational number, right? So 2 plus 2 root 2, what will be the value? Is it rational or irrational? That we need to conclude. So considering 2 you are making common, and 1 plus root 2 will be your in the bracket. So as you can see, this will be the irrational number, right? So consider, I'll give to give you more clarification, I am just giving root 2 as a 1.414 and something till infinity. Okay, because you cannot write in p by q form, and it is the numbers are keep on changing. So again, what will happen if you do 1 plus root 2? It will be 2.414, right? Because your decimal points will not be varying, you are adding 1, right? And if you multiply it with 2, what will be the value? Then it will be 4. Then it will 4.828, like that till infinity. So what you can conclude from this is, whatever you are doing with this number, it is still continuing till infinity, and as you cannot write in p by q form, we can call it as a irrational number. Hope you understood this point. So if there is any rational number added with irrational number, for sure the value is irrational, and you can conclude the this statement using any numbers, whatever comes into your mind. Okay, so going on next, what will be the product or quotient of a non-zero rational number with an irrational number? we need to prove it is irrational. So how we will do it? So same, this is a rational number, p by q form, 1 is p, 10 is q, and multiplied with irrational number which is 5 root 2. So the final value will be 5 root 2 divided by 10. 5 ones are 5, 5 twos are 10, right? So consider again, same thing we'll consider. Root 2 is for 1.414 and it will go till infinity, and we will divide it by 2. So again, when you divide it by 2, it will be 0.707 and it will go till infinity. Simple. So you can still say you cannot write in p by q form, right? That's why it is irrational number. But what if we add two irrational number? Both are irrationals, right? So now if we add, first I'll just write this equation, 2 root 2 into 5 root 2. So you know 2 and 5 will multiply with each other, 10, and again root 2 will be multiplied with root 2. So root 2 square will be square root and square will cancel each other. So 10 into 2, which is 20. Correct? You can see, you can write this as a 20 by 1, right? P by Q form. So you can say like this is a rational number, right? So can you conclude that if two irrational number multiplied, divide, subtracted or added with each other, you will always get some rational number? No. So this is the one example I have given you. Now we will consider some other example like 2 root 3 into 5 root 2. In this case, you can see 5 and 2 will multiply with each other, and root 3 and root 2 will multiply with each other. Again 10 into root 6, because under root a into under root b equals to under root ab. So 10 root 6, this you cannot write in p by q form. You cannot write root 6 in p by q form. So this is a rational number. Correct? Now consider 2 root 2 minus 2 root 2 plus 5 minus 2 root 2 plus 11. If you consider this equation, so 2 root 2 and minus 2 root 2 will cancel each other. 11 plus 5 will be 16. Again, if you added or subtracted two irrational number, it can give you rational, right? It can give you irrational, correct? So you cannot confirm. So final answer will be, if we add, subtract, multiply or divide two irrational number, the result may be rational or irrational. Correct? And you can prove it with any numbers you can take. So now whatever identities we have used earlier, I have given the background over that. So if there is any under root a into b, you can write it as a under root a into under root b. For example, if it is under root 6, and you know under root 6 will be under root 2 into 3, so 2 will be our a, 3 will be our b. You can write it as under root 2 into under root 3. Easy? Yes. Again, if there is under root a by b, you can write it as under root a divided by under root b. This is good important property. So as we all know, a plus b into a minus b property we have seen earlier. So that value will be a square minus b square. Same thing here, just instead of a, we are writing under root of a. Instead of b, we are writing under root of b. Then next is under root a plus under root b, under root c plus under root d. Again the same thing we are doing. First term of this will multiply with first term of this. First term of this will be multiplied with second term of this. Second term of this will multiply first term of this, and second term of this will be multiplied with second term of this. Easy? Correct. Similarly, a plus b whole square formula we all know. So a plus b whole square will be a square plus 2ab plus b square. Right? Similarly, here just a needs to be replaced with under root a, b needs to be replaced with under root b. Same thing you need to do here. A should be replaced with under root a and b should be replaced with under root b. So final answer will be a plus 2 under root ab plus b square. Just remember this thing, square and square root will cancel each other, right? And we know under root a into b equals to under root ab, right? And under root b square, square root cancel each other. Now we will go with some exponential identities. So consider you have common base, but you have some different exponents. Then if you multiply these two terms, you can just add the exponents keeping the base constant. Easy? This will be very helpful whenever you are doing some competitive exams preparation. There you will get so many questions regarding this. So for example, just consider 2 raised to power 4 into 2 raised to power 8. What will be the value? Just 2 raised to power 12. Easy, because we just need to add the exponents. Next is a raised to power p whole raised to power q. So in that case, we'll just multiply the p and q because it is power of power. Okay. So that's why we need to just multiply p with q. Example is again same. Consider 2 raised to power 4 whole square. So 2 raised to power 4 actual value is 2 raised to power 4 means 2, 4, 8, 16. Okay. And its square is 256. Correct. But here we can directly do 2 raised to power 8, which is also 256. Correct. So easy and helpful. You need to understand this exponential identities as well. Next is same. If you are dividing a raised to power p divided by a raised to power q, then again you need to just subtract it. If you multiplied a raised to power p with a raised to power q, you just need to add it. And this is the very common property. If a raised to power n into b raised to power n, so you can do a raised to power b whole raised to power n. So as we are concluding this topic, so first comes the natural numbers. As we saw earlier, all the numbers from 1 to positive infinity are natural numbers. But if we add 0 in the series of that numbers, then it called as a whole number. Then if all the negative parts are included, negative natural numbers, then it can be called as integers. And if we saw the number in the p by q form, so all the integers like -5, -10, 10, all can be written in a p by q form. So that numbers can be called as a rational numbers. And there are some other numbers which are not rational numbers that we called as a irrational numbers. Okay. So that are totally different numbers from the numbers what we see in the left side. And the combination of both rational and irrational numbers are called as a real numbers. So we go to the next point. Question is, are the following statement true or false? Give reason for your answer. We'll go to the first question. Every whole number is a natural number. So you know 0 is a whole number, right? Is it a natural number? No, not natural. Because natural numbers are only from 1 to to infinity, right? So you can say this is the false statement, and reason is, just we explain, 0 is natural number, right? Every integer is a rational number. So this is true because any integer like -5 or 10, all that can be written in the p by q form, correct? So you can say every integer is a rational number. Then every rational number is an integer. Okay, just now we said here all integers are rational number, but are all rational numbers are integers? So answer is no. Reason is very easy. Consider any rational number like my 1 by 10. Is it integer? No, because in integer only the negative real numbers, negative natural numbers and whole numbers will be available. So it is in p by q form, and it cannot be it is not available in the integers, right? So this is a rational number, but it is not an integer. Okay. Next question comes, find any 5 rational numbers between 1 and 2. Very easy question. Just you need to understand the midterm, for just you need to have some background over the midterm formula. I'll explain here. So consider 1 and 2 are the 2 points on the number series. Now you need to find the 5 rational numbers in between them. So you know 1 is also rational number because it is a real natural number. 2 is also a rational number because it is a real number. All real numbers, all natural numbers are rational numbers only. So you can find a midpoint between these two. So that can be also that can be also rational number only. So 1 plus 2 divided by 2 will be 3 by 2. Here I have explained the midterm between 1 and 2 can be given as the first term plus last term divided by 2. Okay. So now if you need to find another number, you just need to find the midterm between 1 and 3 by 2, which is 5 by 4. Then 1 and 5 by 4, which is 9 by 8. Then you should go for 3 by 4 to 2, which is 7 by 4, and 7 by 4 to 2, which is 15 by 8. Okay. So here we'll end our first lecture, and hope you will understand whatever I am trying to explain. If you have any doubts, just comment it out. We'll reach you and we'll answer all the comments. And thank you.